the
calculus
of
A
rainbow.
X
O
X
O
dot
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 Courtney
Tudla
and
Lexi.
Petrie. A rainbow is an arc of colors formed in the sky in certain circumstances, caused by the refraction and dispersion of the sun's light by rain or other water droplets in the atmosphere.
When a ray of sunlight hits a spherical water droplet, some of it will be reflected by the surface of the droplet, but some of it will enter. As it enters, the light ray will be bent or refracted. The ray then continues until it hits the back of the droplet. Some of the light will exit, but some of it will be reflected back, leaving the droplet on the other side and being refracted again in the process.
As the ray of light passes into water, the frequency and therefore color remains the same. However, its speed will change by an amount that depends on the frequency. A measure of the slowing down of light with frequency is given by the refractive index. Its value depends not only on the frequency, but also on the medium the light is entering, which in this case is water. Although the refractive index between red and violet is only a 0.01 difference compared to their differences in frequency, it is enough to split the sunlight into different colors of the rainbow.
Snell's law says that the refracted ray of light lies in the plane formed by the incident ray and the normal at the point of incidence. The normal is just an extension of the water droplet's radius. The different refraction angles are the reason for the different colors, such as violet and red.
Using Snell's law and the law of reflection, we can work out by how much a ray is deviated in terms of the angle at which it first hits a droplet. In other words, by what angle it is being turned as it is refracted, reflected, and then refracted again. This angle will of course be different for each frequency or color of light.
As the white light hits the raindrop at different angles, the angle of deviation changes, creating the arc of the rainbow. The minimum angle is what gives us the rainbow. The chart to the right shows the different deviations based on the different angles, using the refractive index of red, which is 1.33.
The minimum angle is what gives us the rainbow. The ray entering at the minimum angle is highlighted in red and is called the rainbow ray. The rays that hit close to the rainbow ray cluster close together on their way back out of the raindrop. This cluster of rays is what makes the color more intense. The graph shows that the angles close to the minimum angle have less deviation than angles farther away from the minimum angle, creating the cluster.
Using the refractive index for red, you can find the minimum angle for that ray using the equation above. Using that angle, you can then find the deviation of the ray, which is 137.48 degrees. Your line of sight and the sun's rays form alternate interior angles, so as the ray is deviated 137.48 degrees, you are viewing the rainbow at a 42.52 degrees. So yeah, cones.